All right, today we're talking about geometric sequences. Let's look at this first sequence here. -1, -3, -9, -27. Hopefully you can see here that the pattern in this sequence is that every time we're multiplying by 3 every time to get the next term. Times 3, -1 times 3 is -3, -3 times 3 is -9, -9 times 3 is -27. Whenever we're multiplying by the same number every time, we're going to call that number a common ratio. So in arithmetic sequences, we have a common difference. For geometric sequences, we have a common ratio. And we're going to use the variable r for that common ratio. And in this case, it's equal to 3. Consider this next sequence over here. Pause the video for just a moment. See if you can determine what the common ratio is. Now this one may not be quite as obvious as the previous sequence, but hopefully you were able to determine that the common ratio here is 1/2. You might say that the pattern is we're dividing by 2 every time, but it's going to be a little bit more convenient for us to think about it as multiplying by 1/2 instead of dividing by 2. Now if you had a hard time figuring out what the common ratio is, there is a formula that we can always use to find it if we can't see it very easily. You can choose any term in the sequence a sub n and divide it by the term that comes before. And anytime you do that, you're going to get the common ratio. So for example, in this sequence, to find the common ratio, I could have picked the number 3 and divided it by the term before, which is 6, and 3 over 6, of course, reduces to 1/2, which is our common ratio. So this little formula is a good one to remember to help you find the ratio. Now let's look at the pattern, at what's actually happening with the terms here in this sequence. My first term is 6. To get the second term, we do 6 times 1/2, and that gives me the second term of 3. Now the third term is going to be the previous term, 6 times 1/2, but then we're going to multiply times 1/2 again. And that's going to give me 3/4. I'm sorry, 3/2. It's 6/4, which reduces to 3/2. And finally, the fourth term is the term before, 6 times 1/2 times 1/2, and then we're going to multiply by 1/2 again. And this time we get the answer of 3/4. Now, if I was to rewrite this as an exponential, up here in term number 2, we could say that this is 6 times 1/2 to the 1 power, to the power of 1, because we just have 1/2 here in that term. For the next one, of course, we're going to have the 6 times 1/2, but this time there's 2 of them. So that would be 1/2 squared. In our last term that we're looking at here, we have 6 times 1/2 again, but this time there's 3 of them. So it would be 1/2 cubed. Now notice, on my fourth term, my exponent is 3. On the third term, my exponent is 2. On the second term, the exponent is 1. The exponent is always going to be 1 less than the term number. It even works for our first term here. I could write this as 6 times 1/2 to the 0 power, remembering that 1/2 to the 0, anything to the 0 power is 1, and 6 times 1 would be equal to 6. So hopefully you can see we have a definite pattern here that we can translate into a formula for finding the nth term of a geometric sequence. In this case, the nth term a sub n is going to be equal to the first term. Remember on that example, every time we started with 6, times the common ratio raised to the n minus 1 power. First term times the common ratio raised to the n minus 1 power. So let's do an example here. We have a sub 1 is 5, my common ratio is 4, and we want to find the 13th term. So a sub 13 is equal to the first term 5 times the common ratio, which is 4, raised to the 13 minus 1 power. Or of course you could just put the 12th power. Now multiplying by a number that many times is going to result in a very large number, 83,886,080. So pause the video and try the next example on your own. If you were successful in this example, you should have ended up with 8,192. Now maybe if you didn't have a calculator with you, at least check that you substituted into the formula correctly and know that this is the answer that you would get in the calculator. One thing that we need to be very careful about is whenever our ratio is negative, we need to be sure that we put that common ratio into parentheses so that when we raise it to whatever the exponent is, that we be sure and include that negative in what's being exponentialed here. If you don't put the parentheses around it, then this exponent is only going to go for the 2 and it's not going to include the negative. And then we would have ended up with a negative answer in this example. Let's try a different type of problem together. And this one we're asked to find the 25th term of this sequence, 10, 9, 81 over 10, 729 over 100. Now this is one of those instances where you might not realize quickly what the common ratio is. And when that's the case, remember we have a little formula. Common ratio, you pick any number in the sequence and divide by the number before. So in this case, I'm going to pick the number 9 and divide by 10. So I have a common ratio of 9/10. And I can't reduce that anymore. So we can just leave it in that form. And if you notice, if I multiply 9 times 9 over 10, well, 9 times 9 would be 81, and then we would have 10 in the denominator. So you can see that that is the common ratio. So then if I want to find the 25th term, a sub 25 is going to be equal to the first term, which is 10, times the common ratio, 9/10, raised to the 25 minus 1 power. And if you put that in your calculator, it's going to give you a very large fraction, but we can change it to a decimal, and if we do that, we get 0.797. So again, pause the video for a moment and try the next example on your own. Okay, so if you were successful on this example, you figured out that the common ratio is 1/3, and then when we plug the numbers into our formula, we end up with this fraction that has a very large denominator, and if we convert it to a decimal, you get 2.323 times 10 to the negative 8 power. Calculator giving us that answer there in scientific notation. That's the end of our video today. Tomorrow we're going to practice this in class.